Hi, my name is Sriram Subramanian, Head of Data Science and Engineering at Condé Nast. Here to talk to you about predicting content virality to drive social traffic. It's a mouthful, so we'll take a few minutes to define each of them, beginning with who we are at Condé Nast. So you might recognize our publications: Condé Nast Traveler, The New Yorker, Vogue, Wired. These are our marquee brands with a lot of readership, as well as we own several others that you might also recognize: Epicurious, Ars Technica, and with all of those brands, we have a fair amount of scale at Condé Nast. We have more than 100 million unique monthly visitors with 800 million plus monthly page views and a lot of new content or revised content that gets published on our pages. And this is just for the US. Our international business is about the same size, so you can imagine together this is a fairly large traffic um, for all our brands put together. So that's who we are as Condé Nast, um, and what is social traffic? Social traffic is traffic that we get from social media platforms. So, for example, the New Yorker has a brand handle on Facebook that you can follow. You can follow the New Yorker page on Facebook. We post stories almost every hour. When you click on them and end up on our sites, that is, you would be an example of a social traffic for us. And up to 35% of all our sessions are driven by social media platforms. And so social traffic forms an important component of our audience source, right? So one thing to keep in mind is that given all the controversies over the last few years with social media platforms, these platforms have made significant changes to the way they show these recommendations and these posts to users. So, for example, even if the New Yorker posts an article to their brand homepage, you, as somebody who follows the New Yorker, may or may not see the story, because Facebook or Twitter pushes stories to users that they think have a high chance of engaging the user, meaning that the person would either click or comment or like or share those articles. So we are dealing with a black box that decides who gets to see these posts and who doesn't. Right. So this is indeed a challenge. But what we do control is what we post on social media platforms for our brand handles and how often and when. Right. And like I said, more than a third of our traffic comes via social media platforms, so it's a substantial source for us to cultivate, grow, manage, maintain, so to speak. So that's social traffic. And if I were to look at which articles get social media traffic, right? And I just looked at a recent few weeks, and you can see that 20, you might recognize this as a Pareto law, 20% of our articles get 80%, almost 80% of our traffic. So of course it's important to pick out the winners, right, that form the big portion, 80% of traffic. But what it also means is that there is a substantial traffic of the remaining 20% that's derived from a whole bunch of um, slightly less popular, if you will, articles. And these are what are called thick-tailed distributions. So we have to get those right as well. So it's not just not only important to get the winners right of the 20%, but it also is important to get the remaining 80% of articles. And that is the reason why we were thinking that we need an automated system to figure out what is the right article to post on social media platforms that will get us traffic. And that's where the concept of virality is important. And I'll talk a little bit about what is predicting virality in the next slide. So what is predicting virality here, right? So there are two ways in which we can form this question. One is, can we predict how many page views a piece of content will get in the next few hours? That's one way to frame uh, the virality prediction question. Another way is, can we predict which content should be promoted on social media and when? And a bulk of our, even though we look at both of these two questions, the bulk of our focus will be on the second question. Just to elaborate what this question means a little bit more, more on this next slide. So we publish an article on our site. It starts picking up traffic, and that's this first portion of the curve, right? And we are now at time t. We are here. So what we have to do now is to figure out, if I were to post this article on social media, on let's say on Facebook, how much traffic do we think it'll garner over the next few hours, right? And that is the prediction problem that we are dealing with. So we are trying to figure out what is the incremental traffic that we can get with a social media posting. And there have been people have raised questions around, hey, can't you post every single article you publish? Can't you post several articles every hour and not worry about predicting which article to post? Unfortunately, social media platforms penalize us if our posts don't perform well. So more of our posts that don't perform well, the black box will start suppressing our posts to users. So that's not what we want. So we want to be able to figure out what our users like and will click on, will share, will comment on. Those are the ones that we want to post. At the end of the day, these platforms also want to engage their users. So doing what we can to engage our audience is usually the best solution here. So that's why we've engaged on this project, right? Why this question is so important for us. So with that, what are we trying to do? We're trying to learn a policy. This is reinforcement learning speak. And this policy here would figure out, given the state at time t, which is what's happening to the content so far, this article, what are the descriptors, who's written it, which section site, which section channel it's part of, what are external trending topics, let's say on Twitter. And then there's an action for at time t, which is whether to post this article on social media or not. And then the reward we define as the predicted page views that we would get in the next few hours. Based on that, we have to learn and what we call an offline policy. And this has to be learned from our past data. One note here on past data, or log data as we call it. These posts are actually selected by editors and writers. And the selections are made with the brand image in mind. So we don't want to post anything that's too controversial, that could reflect poorly on the brand. So there is a lot of editorial oversight on what gets posted. It's not something that we can post any article that we want. So the historical data is significantly biased towards a certain kinds of pages and content. So it's not a perfectly valid randomized data set that we can learn well, any machine learning or any policy that we can learn. So that's something that we bear in mind. So all of our reinforcement learning approaches are tailored with that in mind, that this log data is a non-random data set. Right. With that, we develop a model that learns this policy, and we'll talk to you a little bit about what that solution here is. And the first step is model training. So we learn from our past performance on Facebook for all our social media posts and editors' feedback. What is the performance? And we train a model based on that. We monitor real-time trends. So we have live monitoring of our sites for every single article. We see how many pages each is getting in the last few minutes, in the last few hours, and make predictions using our model as to which content is likely to succeed on social media, right? And push it to our social media workflow tools. And that's where the editors review the recommendations. They optimize what is called the copy, which is the bylines that go on social media, the image that gets selected to display, and hit publish, and which is then pushed to Facebook, Twitter, and elsewhere. And from there, those black boxes then decide who gets to see these posts. So to summarize, we call the solution Falcon. So it is an AI solution that, one, discovers trending content. It predicts how it will perform if it were to be posted, and then it recommends what to post and when to our editors, social media managers. So what are the key features of Falcon? One is content discovery. So this makes content discovery very efficient for our editor, for social media managers. Earlier, social media managers had a giant Google sheet where they just selected pieces of content to post. So this automates that and makes it much smarter, much more efficient, taking into consideration all the variables that's happening at this point in time. The second thing is workflow. We push those recommendations. Once the content is discovered, identified for posting, it's pushed into social media tools. Internally at Condé Nast, we use a prominent social media platform for managing all our social media accounts. So it's completely seamless, transparent to the end user. It shows up in their favorite social media tool as a recommendation. And then there's an editorial integrity piece where there is oversight in terms of what gets posted. And we also automate all the rules that we know of a priori. So if we know ahead of time, certain kinds of content, certain channels cannot be published on social media, we can automatically implement it underneath in the system itself to prevent recommendations of what's not supposed to be posted into the system. So there is an editorial integrity piece here. And of course, all of this is done with a view of optimizing traffic on our sites. So we are always identifying the right articles to post that will improve not just traffic, but also engagement on social media platforms like shares, replies. So these are the key features, and it also gives you a view into what our usual challenges are for our social media managers, so that we attempt to solve. With that, what has been the results, right? Eventually, the results are what speak for the solution. So the year-on-year results for one brand. So brand is what we call one of our publications. So the first publication that went live, the first thing is that we wanted to measure was efficiency in content discovery. So we actually made 20% more posts because now this saved time for users so that they don't have to spend time on searching for content. So this is definitely makes the whole content discovery process much more efficient. So we were able to make 20% more posts in the same time duration. Social traffic, we were able to drive it up by more than 50%. This is the main indicator. This is what we were going towards. The previous year, the social traffic was actually down from prior years because of changes in the black box that I had mentioned. The controversies in 2018 in social media led to, so Facebook, for example, suppress any news articles. So brand handles that you might have followed, you would have seen fewer recommendations from them and more recommendations from your friends and family. We were able to counter this with more appropriate recommendations. So we actually saw a lift in social traffic. The final piece was lift in engagement, which is likes, shares, comments. This is one of the big things that we are also going for, which means that we were doing more relevant content for our consumers, right? More we engage with our consumers, better we get as a brand. We get more information back to us in terms of what works, what our users like, and what is relevant at that point in time. These are high-level measures that we were always measuring us by as a social media, from a social media perspective. We also introduced two new measures. One is traffic to older articles. See, older articles is where content discovery and efficiency in content discovery is very important. The new articles, yes, we publish only a handful every day. It's a lot easier to pick out the new articles. The older articles, we have a repository of, in some cases, more than 100 years of history. For example, Vanity Fair, New Yorker, they all have very long historical repositories. picking out relevant articles at that point in time to post is a true test for an AI powered automated solution. So we were able to actually increase traffic to older articles by more than 120%. This has been an amazing result. That's one new metric that we've introduced for this solution. The second metric that we've introduced is what is the traffic in the first 48 hours of posting. So this is what we call the virality quotient. So we've increased traffic in the first 48 hours of posting by 35%, which has also been an amazing result for us. So this means that as soon as we post, there are people who are following, clicking, landing up on our sites, which means that we are engaging with our users on a more timely basis. Where are we today with this system? So 13 brands or 13 publications are using Falcon on 2 major social media platforms, Facebook, Twitter. We want to grow this. 35%, nearly 35% of all our social traffic are from posts from this AI solution, Falcon. And almost all our older content is now posted via Falcon, right? This is what we set out to do, and much of the goals are done. What do we want to do next? One, platforms. We want to roll it out to more platforms. For example, Instagram. Instagram is a much more visual platform, so we want to build new models that would accommodate with the visual component, and that makes the images much more important. The second is signals. So we want to be able to process external signals, especially Twitter trending topics, in a much more intelligent way. As you all know, Twitter trending topics, Google search trending topics, they're written in a language that's very different from the language that's used in a formal publication like the New Yorker. Twitter language tends to be much more colloquial, slang. Translating that using natural language models and relating it to our formally written content is a challenge. And we are working on new natural language models that would help find those similarities, and using those signals find relevant content and surface relevant content. The final thing is, of course, new reinforcement learning architectures that we can use and improve our models. This is a continuous process of improvement, especially given that so much action is happening right now in reinforcement learning. New toolboxes, new model architectures are coming in, new ways to set these things up in terms of technologies and technology stacks is coming up. So we are always on the lookout for new approaches. With that, that brings an end to my presentation. Thank you for listening to me, and I'm happy to take any questions you may have.